I am taking this physical money into that physical Sainsbury's supermarket because in order to test a maths theory, I need to find some combination of items that when I buy them, the self-checkout will give me a 50p coin in my change. Here we go. I can buy a Oxford exam set for £4.50 and we can examine what the self-checkout's gonna do. Okay, here we go. A cash and card. I'm gonna scan this barcode on the back. Okay, notes in. Note in. And change will come out here. What? There's my £5 note. My change, 2 20s, 2 5s. What the heck, Sainsbury's? 4 coins when 1 would do. We have a perfectly good 50p coin. Here in the UK, we have 1 and 2 pence coins, 5p, 10p, 20p, 50p, and then £1 and £2, which I'll be referring to as 100 and 200 for consistency's sake. Above that, it's a £5 note. Now, of those 8 coins, for some reason, the Sainsbury's self-checkouts do not have 50p or 10p coins. You can spend them, but the coins you put in go into a different bucket. They're not reused to give change to someone else. All new coins have to be loaded in for change purposes, and they don't put in 10s, they don't put in 50s. So your worst case scenario, if you should get a 50p coin, you get 4 coins instead, 2 20s and 2 5s. That's 3 more coins than you need. If you need to get a 10p coin in your change, you'll get 2 5p coins. That's 1 extra one. But they don't combine, because 60p, you just get 3 20s. So worst case scenario, you can get up to 3 more coins in your change for the same value of change. And just out of curiosity, I knocked a little bit of code together to take every conceivable value below 500 and then across all of them average the number of coins you would get. And in normal use, across all 8 coins, you expect to get on average 4.6 coins in your change. Because Sainsbury's are using 2 fewer, you get on average 5.9 coins in your change. That's over an entire extra coin. It's ridiculous. And we'll get to why Sainsbury's are doing that later, and it's not good. But given I'd put together some code that could test the effectiveness of different combinations of coins, I thought I'd see if I could do an anti-Sainsbury's. What if we wanted to add a coin to make things better? All right, give me 1 second. I'm just gonna knock a quick coin together. All right, there it is. I've just struck a £1.33 coin. This is the coin the UK is missing. So here's what I did. I took the standard 8 coins and then I added 1 more coin for every possible value between 1 and 499 and then averaged how many coins you get in change, assuming all values between 1 and 499 below the note are equally likely. And here's the plot of the average number of coins for every possible value we could add into the mix. And there are two optimal points, 2 local minimums that are 133 and 137. I assume the general public will be more open to a 1 1/3 pound coin as opposed to a 1.37 pound coin, but either one, you add it in and the average number of coins in your change is now a mere 3.9. That's under 4. That's an improvement. But can we do better? Oh, you know we can. I'll make sure to get the 8 up the right way. Don't get me started on 8s that are up the wrong way. Makes me angry. So Matt, why did you have to move office? Beats me why they didn't want me as an office mate. So forget the £1.33 coin. Instead, we're going to add a 77 pence coin, and we're going to add a £1.84 coin. And with these, combined with the 8 we already have, it brings the average number of coins you get in your change down to 3.6. Come on! And we can keep adding coins, but at this point, I'm like, you know what? Eventually, we're just going to have 1 coin per value. And it'll be an average change of 1 coin, because there's 499 of them. At some point you've got to say, look, we can't just keep adding coins. Maybe 8 is already too many. What if we just replaced more of the ones we've already got? It didn't take much to alter my code. So instead of adding every possible coin to all 8, it would take every subset of 7. So like remove all the possible coins one at a time. Actually, except for the 1p coin, we need that. Well, we need that. We'll get to that in a moment. But we do need it if we want penny accuracy. So it took each of the other 7 out one at a time, tried every possible replacement, and your optimal improvement is to get rid of the £1 coin and replace it with a £1.23 coin. Now, I'm not going to belt that out of metal, partly because it's super loud, and fun fact, we've had a complaint from someone in a nearby office, but also because just replacing the £1 with the 123 brings the average down from 4.6 to around about 4.2, but we can do better because I just left the code going. It started again and checked if there was another replacement that would be even better and another one that would be even better. It turns out there are 3 more. As well as £1 becoming £1.23, you can get rid of the 2, the 10 and the 50p coins and replace them with a 13, a 37 and an 88 pence coin. And now your average number of coins in change is down to 3.9. We're back under 4. We haven't had to add any, we just got to replace them. And I was like, wait a minute, is that the best? There's an interesting point here though, because my search of finding what one swap is optimal at any point in time doesn't actually let you search all the possible solutions, because you can't just change a coin in isolation. It depends on the other ones. So what you need to do is look at whole new sets, because you don't just like choose a coin when you're giving change on its own. It depends what other coins are available. So you need to change all of them at once to find the global solution. And thankfully, someone who's better at programming than me has done just that. I believe the optimal coinage problem tracks back to a 2002 paper. What the country needs now is an 18 cents piece. However, I first came across it when my friend Adam Townsend, a mathematician at Durham University, wrote an article for Chalk Dust. And at the time, Adam was able to work out the optimal solutions across all possible combinations of coin values for the UK for everything up to the case for 5 coins. So we now know if we only had 2 coins, we'd have a 1p and a 22p, and your change on average would have well over 20 coins in it. 3 coins gets us under 10 with a 1p, a 14p and a 61p. And at the time, 8 years ago, the computation fizzled out after 5. When I contacted Adam saying I was finally making a video about this, maybe we should dust off the code and give it another go, straight away he got the case for 6 coins, which was very exciting. Not long after that, we got 7, and then it seemed like we were not going to get 8. The code was going to take so long to run. It was hard to justify that amount of processing power. Until one day, Adam was struck with inspiration, changed the code, made it more efficient, and now we have an answer, which is why I'm filming this bit after all the other stuff you've just seen, because it literally just happened. And I can now present the official 8 coin solution. If we swapped the 8 current coins used in the UK for these, and come on, we get a £1.11 coin, we would have way fewer coins in our change. Would bring the average all the way down to 3.82. So good, and I was so excited. You better believe I 3D printed them. So there's a £1.58 coin. We got the £1.55. If you're thinking these are just way too big, it's because I wanted the volume of these to be proportionate to their value. So if you go all the way down to the 1p, that's got 1/158th the mass of the £1.58 coin. So what it means is if you get your change and you just chuck all the coins on some scales and weigh them, it'll give you the exact value. How good are these? Available now, the most optimal set of 8 coins possible, and all of these could be yours if you just convince the government
to change to these and then do a lot of complex arithmetic anytime you want to make change, or because of the scaling volume, just weigh your change and get the exact value straight away. It's so dumb.
Now you might be thinking, if we found these coins via an exhaustive search, is there a... Hey, speaking of money, it's time for me, Business Matt, get out of here. So these fantastic coins we have printed for the video were all printed on that Bambu Labs X1 printer behind me, and they are sponsoring this video, which is why I'm gonna say it's a printer so good you can literally print money, like actual money. I don't think we can legally say they can print money. Look, who is the business finance expert here? You are. Correct. I'm the one wearing a jacket. That's how you know I'm Business Matt. Get out of here. That's how it works. Bambu printers, so good you can literally print money. Legality to be questioned.
The Bambu Labs X1C is a high-speed, high-quality 3D printer. It can take multiple colors at once, and it's got all sorts of smart features which actually work, and it means even I, a 3D printing novice, can print all sorts of fantastic, multicolored things.
And thanks to everyone who sent in models after the last promo we did for Bambu, including Andreas Muller, who sent this. I said if enough people used the link and we got to do another promo, I'd print out files people sent in. So Andreas sent in this. It's a ring of regular dodecahedra. So in theory, this could be like, will this go around my head? It won't go around my head.
But Andreas has put this model and other longer, more flexible ones that will go around your head here on MakerWorld, the Bambu Labs website where you can download all sorts of great models.
And thank you to Adam Luter, who sent in some assembly required. This is what's called an industrial dice. It's based off a design that James Prop came up with. I need to go home, glue this together, then I can roll it, and I'll have a link below. You can check out the maths of that. So do check out the link in the description below, and if enough of you click it, we'll do another one of these. Send me in more ridiculous models, and I'll print them out. Business Matt, away! Is he gone? Okay, phew. Sky, we're safe. Come on. Up here. Good girl. Sit. Lie down. There you go. Now, if you're thinking, if we found those coin combinations via exhaustive search, surely there's a more clever way of doing it. And actually, when the results came in for the 6 coin setup, I thought, you know what? That £1.40 and that 99p are awfully suspicious.
Of course, as these numbers were coming in, we were looking for patterns, so we could just generate them instead of having to do such tedious, exhaustive searches. And at the point when we got to 6, so I hadn't seen 7 or 8 yet, I was like, wait a minute. 99p? £1.40? Well, £1.40, that's almost the square root of 2. Well, 100 times it. Wait, 99p? That's about 100. Hang on a minute. It turns out £1.40 divided by 99p is root 2. How interesting, but are there other ratios between the coins we were finding which was root 2? Well, we can spread this out a little bit to give us a bit more room, and of course I calculated the ratio between every 2 consecutive coins for all the solutions we found, and there's our root 2, and there's kind of root 2. Is that root 2? What about this one? That's root 2-ish. Now, I believe these are close enough to indicate something is going on. Now, we don't actually know what. If you come up with a way to generate these, that would be, as far as I know, all new maths. And it seems like it's got something to do with square roots. You could argue I'm just reading tea leaves here, and I'm overfitting to what I'm seeing. And there is a line, so the one here, 1.597, that's pretty much exactly the 4th root of 6.5. But I feel like that's an accident. The root 2s, however, that might be something. And the reason I think it could be an indication of what's going on is square roots do abound. And if we have a closer look at the 2 coin case, so you get a 1p coin and some other coin. Why 22 or 23 pence. Why are they equally good? Well, in our case, we have to make change up to £5, 500 pence, and the square root of 500 is suspiciously right between the two equivalent values. It seems like square roots have a lot to do with this. And the 2 coin case is the nice, simple starting case we can actually investigate. So let's say we have 2 coins. One is worth a single pence because we need penny accuracy, and then we have some other coin of some other value, and we have to make change for any value from 1 up to some value capital N. Well, I mentioned this to Adam. He had to think about it, and he ran his code again and put together this plot. And the blue is what came out of his code, and the orange is when you fit an equation to it. And it looks like the equation of the expected number of coins for when you add in some X pence coin, and your capital N is 500, is a half 500 over X plus X. But why? And it turns out that's true. And here's why. If you think it through, the number of coins you need for some value little n, so that's some value between 1 and capital N. For one specific case, you're making change. You go, okay, well, I want to use as many X pence coins as I can because they're the bigger value coin. So you take the target N divided by X. That's, well, you got to round it down. That's how many X pence coins you can use. And the rest of it, whatever the remainder is, and we can calculate the remainder, that's how many 1 pence coins we need. So that's the total number of coins for any specific value little n. If we want to do all the values to capital N, well, we just take 1n and then we sum it up for all the n's. Divide by n, and that gives you the average number of coins for some coin X. Here's where we can have some maths fun. And then, by the way, this is all too fast for you to be able to follow in close detail. You can pause it and have a good think and work it through yourself if you want. But broad brush, you convert that to an integral because we can actually work that out exactly. You do that integration, and the equation for the number of coins on average for a coin X is this. Look how neat that is. And if we want the minimum, what's the best X? Well, we just differentiate that, set it to 0, and would you believe it? It gives you X equals the square root of N. That's where the square root comes from, at least in the 2 coin case. Very sadly, we can't extend this to 3 or more coins because of an assumption. See here where we had the number divided by X? We're basically saying do the biggest coin first. Do as many as you can, then do the next coin down. And that, while it seems intuitive and logical, that's called the greedy algorithm. And very sadly, it doesn't always hold.
The greedy algorithm is where you take the next biggest coin to get up to the total you're aiming for. And I hate to admit it, but it means that these are not very practical because in over half the cases, 320 out of 499 change scenarios, the greedy algorithm doesn't work. So if you had to make change for 31 pence, you'd be like, well, we've got to use the 28 first because that's the biggest one under 31. And then we make it up with 3 pennies. And that would be 4 coins because you went biggest first. However, if you skipped over the biggest one and instead you picked up the 21p, you'd then only need 2 5p's to make up the total. That's only 3 coins. And our normal coinage doesn't have this problem. This better coinage does. And the worst case scenario, by the way, is if you had to make £2.28 with change. And you'd be like, oh, how am I going to do that? You go, well, the biggest coin's the 158. We'll do that. We then need 2 28s. We need 2 5s. And then we can make up the rest with 4 1s, which is a lot of coins. And you've completely neglected to notice that £2.28 is just the 155 and the 73. You can do it in 2 coins. That's 7 fewer. It's just super not obvious. So not only are these coins unusual numbers that make the arithmetic difficult, but you can't even do it the normal, easiest way. You've got to use difficult numbers and do it the hard way. So there you are. Opportunity for way more maths, in my mind. However, now I return you to past Matt. He's probably banging on about what's more practical. There is another solution to simplify change that we're overlooking here, and it is, dare I say it, practical, which I appreciate is the opposite of what we normally do here at Stand Up Maths. And if you've been looking at these coins thinking, there's no way I'm using those coins, and there's no way the general public are going to be adding up ridiculous coin Denominations, well, it's simple. We keep all the values we currently have, and to simplify it, we just get rid of the 1 and 2 pence coins. And just by getting rid of them and rounding our change to the nearest 5 pence, we will drop the average number of coins all the way down to 3.4. Way better. And if you think, well, hang on, people aren't going to do that. People won't be happy rounding their change. Well, in Australia, they got rid of the 1 and 2 cent coins. They had an identical range to what we have in the UK. Got rid of 1 and 2 cent coins in the early 90s, and for over a third of a century, it's worked fine. For more on this, we go to On Location Matt. Thank you, Studio Matt. No, you hang up. Oh, we're not doing that? I thought we were... Anyway, I'm here on location in Australia, and I can confirm. I remember this, in the 90s, we got rid of the 1 and 2 cent coins, and nobody cared. Well, no one cares now. We still have the notion of 1 cent, because if you pay electronically or, with a card, you pay to the nearest whole cent. If you pay cash, rounded to the nearest 5 cents. So actually, if you're a little bit strategic and you choose between cash or card, depending which way the rounding's going to go, you can save literally ones of cents in a lifetime. But what about self-checkout machines? Well, of course, there is a supermarket here at the beach that has self-checkouts, and I've worked out if I go in there and spend these $10 and the machine has to give me $3.85 change, it should do it with one of all 6 different coins available, if it has them. Let's find out.
As is tradition, once I got to the supermarket, I went to the stationery aisle. This time I found a clear plastic ruler, 30 centimeters, for $2.15. I just have to add to that a single box of barbecue shapes for $4. Wait a minute. 2 half-price boxes of barbecue shapes for $4. Bonza, and that's going to give me exactly $3.85 change. Put in my $10 and here comes the change. There's a $2 coin, a $1 coin, and following that, what? A heap of 20 cent coins? Where's my 50 cent? Where's the 10?
Unbelievable! Coles have given me 3 20-cent coins, 3 coins, when I should have had a 50 and a 10. That's 1 more coin overall than was optimal. What on earth is going on with self-checkout machines? I'll tell you what, I'm going to email Coles, and if they reply, I'll edit their response in right now. Nothing? Nothing. I guess they didn't get back to me. The point is, whatever's happening with these self-checkout machines just doesn't measure up. But that's it from me here in Australia. No longer have 1 and 2 cent coins, although interestingly, never replaced them with anything else. Back to you, Studio Matt. Thank you, On Location Matt. No, you hang up. Oh, we're not doing that bit? Oh, sorry. Anyway, so if we get rid of the 1 and 2 pence coins and we replace them with 2 new coins, which Australia didn't do, we can do even better. And now we don't get any weird values because everything is a multiple of 5. And for some reason, everyone's okay with that. So if we get rid of 1 and 2 and replace them with 165 and 225, we bring the average number of coins in change in the UK down to 2.6. Under 3. How good is that? And if you want to take this opportunity to simplify the whole system and not have 8 coins, we could go down to just 7 coins by replacing 1 and 2 pence with a single £1.75 coin, which is quite nice. And actually, Adam had an idea for the design of that coin.
When Adam presented his initial findings at the Mass Jam weekend many years ago, he showed the original design for the current coins, which has this fantastic shield pattern. You can see all of it on the £1 coin and then fragments on it of the 6 other coins of lesser value. Now, since then, the £1 coin has been updated to a different design, but we still have the shield on the other coins. It's a wonderful little thing that often people don't notice, and when they do, it's a fun Easter egg. But Adam realized if we took out the 1 and 2 pence coins, we even further lose the shield. So if we're going to replace that with a £1.75 coin, it needs to fill those 2 gaps at the same time, and this is what Adam designed and presented with a sufficiently straight face in front of a room of other recreational mathematicians, and I thought this design was so great I asked Adam for his slides, which is why I'm showing them to you now. I think it's some of his best artistic work, if I'm being honest. I mean, look at that double £1 75 coin. The lion is roaring. That's excellent. But no one's gonna actually try and make it.
You know I printed it. There it is. I managed to recreate Adam's incredible design. I mean, you could just see the shield. Now this is a 2:1 scale because I tried to print it the exact right size and my 3D modeling abilities are not good enough yet, but that's still a proof of concept. That's a prototype. Now, that's a practical coin. I'll be honest, my vote is just dump the 1 and 2 pence coins, don't replace them, simplify it down to a mere 5 coins, so tidy. And other countries have got a much smaller set of coins. For example, the currently United States of America. And we have, sadly, on location Matt couldn't make it, but we do have a US correspondent for the channel, Rolly.
Hey, how's it going? I'm Raleigh Williams. I'm here in the United States of America. I'm from the YouTube channel Climate Town. Check it out on youtube.com. In America, we have 6 coins, but if you think we're using all of them, you're out of your goddamn mind. We only have 4 in normal circulation. 2 of them we never use, including the $50 and the honkin' dollar coin. This thing weighs as much as a house. We just have it to show that we're better than everybody. So that's how we do it in America, and as far as I'm concerned, that's how everyone should do it all around the world. USA, 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 catch the fever!
Indeed, USA. And that actually answers our question about Sainsbury's, because if you have a close look at the Sainsbury's self-checkout that I was using, it's an NCR model.
Plus, you might have noticed the machine in Australia also NCR.
And the company, NCR, that makes them is an American company. The self-checkout machines are designed for American coinage, or at least designed for countries with fewer coins. I don't know why it's 6. Maybe it's the 5 normal ones, and then they've got the $1 coin as an option, but they're definitely not designed for 8 coins. So Sainsbury's, they're not going to pay for a whole new type of machine. The UK market's obviously not big enough for that. So what they've done is just gotten rid of 2 of the coins. They took out 50p and 10p. But are those the best 2 coins to take out? I had to look into it. Do you want to see? Do you want to see a plot? Of course you want to see a plot. I've got a table here of every pair of coins that could be removed. I've only filled in the ones where like it's a unique pairing of coins, and green is good, red is bad. And the best one here is if you take out the pound coin, the 100, and you take out the 10p coin. So instead of doing 10 and 50, they should have done 10 and 100, because that would give you an average of 5.41 coins in your change. But they didn't do that. They didn't do any of these. All of these are better. In fact, if they took out the pound and any of the 2p, 5p, 10p, and 20p, it'd be better than what they've currently got. Now, maybe they thought people wouldn't tolerate there not being a £1 coin, so they didn't take that out. But that's the optimal solution. Or they could have taken out the £2 coin and the 10p coin, or they could have taken out the 10p coin and the 2p coin. All of those are better. Instead, they took out the 50p and the 10p, which is now like, what, the 7th best option. And I have no idea why they did that when there are way better options. Actually, you know what? I might email them. I didn't think to ask. I really just worked this out, to be honest. You know what? I'm going to send them an email, and if they give me a sensible explanation, I will put it in the edit right here. Nothing. I guess I didn't reply. Honestly, Sainsbury's. So in conclusion, I don't know, money is terrible. I'm not, no, coins, I mean money is made up, but coins are terrible. I mean, I haven't used physical money in a very long time, and that's the first time I've gotten change from a self-checkout machine in, I would say, about a decade. Because we don't need physical money anymore, and that's why I'm very pleased to announce Mattcoin. Wouldn't that be special if that's what I was doing? No. Hey, thanks for watching. Thanks for supporting the channel. By the way, I don't need another one of these in my life. So if you would like this, or indeed the coins, I will sign the coins. I'll sign this. They're all on eBay. You can pay electronically or post me money. No, you can't post me money. All the money goes to charity for these. Thank you to everyone on Patreon who gives me real digital money to keep the channel ticking along. Huge thanks to Adam Townsend for doing the maths, inspiring this video, helping me put it together. And of course, thanks to Jeffrey Shallett, who did the original What This Country Needs Now is an 18-cent piece. I'll link to all of it below. Thank you for watching. Bye. Be the change you want to see in the world. That's what I should have said. This is the change I want to see in the world. This is not a serious career.